Okay, this is Business 342, page 71 of the lecture. Problem: consider a portfolio with equal amounts invested in 3 stocks. So equal amounts means 1/3, 1/3, 1/3. Use this information to find the expected return. Remember, the expected return is a weighted average and the variance of the portfolio. There's a couple of different formulas you use for variance. When they're giving you the probabilities, you use the one formula that we just did on page 70, and I'll show that to you again. And that's where the variance of the portfolio equals the return of asset 1 or whatever minus the expected return for the portfolio. So this is x minus mu squared times the probability of that plus the return of asset or portfolio 2 minus the expected return for the portfolio. This is typically an individual asset squared. So this is x minus mu squared times the probability. So when they give you a probability and you can figure out the expected returns, obviously, this is the formula you use. When they give you correlation and standard deviation separately without the probability, then there's a different formula that we'll be showing you just in a little bit. So you go through and figure out this table. So first you figure out the expected returns, and for that you need the return for each one of these different states. So that's the weight times the return, the weight times the return, the weight times the return. So 0.333 times negative 5, 0, so you didn't figure that one, 0.333 times 20. And remember, I do these, when they talk about return, we do these as whole numbers, just because they want it to come out as a percent as a whole number. So you don't do these as a 0.05 in the calculation. It's just easier to do them as a whole number. Use the probability as a decimal, but not the returns. So you figure out each one of these lines. So 5%, 11.67%. Again, this is the weight times the return, the weight times the return, the weight times the return, which are these numbers right here. You add them together, and you do the same for line 3. To get the expected return now, it's a weighted average. You take each one of these times the weight. So 5% times 0.25. So 5 times 0.25, 11.67 times 0.5, and 18.34 times 0.25. And that gets you to an expected return on your portfolio of 18.01%. Now that you've got that, you go through and figure out the variance for each one of these states. Okay, so 5 was the expected return for this state. So this is x minus mu squared. Okay, this becomes mu. This becomes your mean. Okay, 18.01. So x minus mu squared times the probability of that happening. X minus mu squared times the probability of that happening. Of course, this is just the return minus the expected return, x minus mu. Okay, and you do that all the way through. You add that up, and remember, this is the variance. So you're just getting the variance in this case, but that's all they ask for. They're usually going to want standard deviation, which standard deviation is the square root of that. So don't get this answer when they're asking for standard deviation and think you've answered it, because you still got to take the square root for that. Okay. All right, so moving down the page, talks about portfolio mathematics. Consider a portfolio consisting of 2 assets. One's got the weight of A, WA, and WB represent the percentage of the portfolio, so the weight of the portfolio. Okay, so to figure out the expected return, you would take the expected return equals the weight times the return plus the weight times the return. Okay, and this is when they've got 2 of them. The reason they only give this as a 2 example to explain a little bit lower is you've got a covariance factor here, and that's really complicated to figure out for 3 different stocks or assets, I should say. Okay, so this is the other formula. When they give you like correlation or covariance and the weights, but they don't give you the percent of probability, then you're going to use this formula. and it'll typically only be for 2 assets. Okay, these ones you could figure out with as many assets as you want. In this case, they've got 3, but these are harder to. They've got 3 right across there, A, B, and C. These ones, since the covariance is hard to figure out, they're probably not going to ask you to do that. So anyway, in this case, when you've got that information, you don't have a probability. You do not have a probability in this problem. That's when you, and they give you a correlation or covariance. That's when you're going to know you're going to use this formula. So it's the weight of asset A squared times the standard deviation. So you got to figure out the standard deviation still. So the weight of asset A squared times the standard deviation squared of A plus the weight of B squared times the standard deviation squared of B, or the variance, whatever you want to call it. They're both the same. This is either the variance or the standard deviation squared, plus 2 times the weight of A times the weight of B times the covariant, or that same formula up to here times 2 times the weight of A times 2 times the weight of B times P of AB, security A and security B. P is correlation. So the correlation of A and B times the standard deviation. Now these are standard deviations, they aren't standard deviation squared. Standard deviation of A and standard deviation of B. Okay, so that's a formula that you're going to use when they give you like correlation, or if they give you covariance. We could figure that out also. I'll show you how to figure that out. Okay, said note that the risk, the variance of the portfolio, remember variance is the risk also, because variance is just standard deviation squared, but you mostly see it as standard deviation of the portfolio depends on the risk of individual assets, which is standard deviation of the individual assets, so you can see that better. The weights, portfolio weights, and the correlation between the assets. Okay, so the correlation between the assets is either the correlation or the covariance of PA times the standard deviation of AB. I think, yeah. Okay. For a portfolio, and now it says right here, for a portfolio formed of 3 or more assets, we can generalize the above formula for the expected return easily. And when they mean the above formula for 3 or more assets, it's going to be more like the formula above the expected returns. Oh, you can use this for 3 or more assets. Okay, and that's this formula right here, because that's a weighted average. So they're just telling you for 3 or more assets, you can still use this, the weighted average, to figure out the expected return. It says, but the variance of a portfolio formed of 3 or more assets is a bit complex. The variance figuring out this way they're talking about is a bit complex, since we have to allow for the covariance between pairs of assets. So they're saying this one still can be used like it has been for the other ones to figure out the expected return, because that's just a simple weighted average. Remember, a variance is not a simple weighted average. That's why there's a formula for it. Even with the other one, it's not a simple weighted average. Variance and standard deviations are not simple weighted averages. We're expected returns, and when you find out betas on portfolios are weighted averages too. But variances are not. So this formula, you won't see this you won't have to use this on your tests or quizzes, I'm sure, when there's 3 assets. Okay, in this course, we will use math portfolio covariance only for computing the variance of 2 assets. For multiple asset portfolios, we can derive the portfolio return in each possible state and then compute its variance with the earlier method. In each possible state, they're going to have a probability with it. So that's what I'm saying. If you've got a probability, you're going to be using the other formula for figuring out variance. If you've got a correlation and standard deviations, correlation or covariance, it would be the big tip. If you don't have a probability and you have a correlation or covariance, you're going to be using this formula. If you have a probability to figure out the variance, you're going to go back to this formula, which is the standard x minus mu squared times the probability plus x minus mu squared times the probability, where x is the return at a certain state times the expected return for the portfolio squared times the probability for that state, like a boom or a bust. That's when they talk about states, you know. Okay. So that is page 71 on your workbook.